Hey guys, so we're back with some more array problems, and this is another really well known array problem known as best time buy and sell stock. And it's pretty much a simple parsing, but again, there's a better way to do this in the brute force, and I'll kind of be showing you that today. So let's just get straight into it. So let's assume that you have an array for which the ith element is the price of a given stock on day I, right? So you can see this integer array prices as just a list of prices on any given day, right? So let's say we have just like, this could be a list of prices in a 6-day trading week, right? Or whatever. If you're only permitted to complete at most one transaction, so buy one and sell one share of the stock, design an algorithm to find the maximum profit. Note you cannot sell a stock before you buy one. So a couple things, right? As many of you are probably well aware, the game with trading stocks is you want to buy low and sell high to make a profit, right? And you cannot sell a stock before you buy one. So we have to complete the buy order first before we can complete the sell. And the reason that makes this problem a little bit more interesting is if we didn't have this, we would just be finding the range of the elements in the array, which is pretty mundane, right? But this makes it a little bit simpler or a little bit more complex because we want to find, what's the maximum differences between two elements where one comes after the other. It has to be specifically one coming after the other, right? So look at example 1. Even though our maximum element here is 7 and the minimum is 1, the output is only 5. And the reason for that is the most profitable play would be to buy on day 2 and then sell on day 5, generating a profit of 5. You wouldn't want to buy at 7 because it's obviously the highest price, and you wouldn't be able to turn any sort of profit because it just goes down from 7. And you can't buy at 1 and sell at 7 because after you buy at 1, the price never gets back to 7. Right? So in example 2, we see this: the price starts at 7 and just continuously decreases. The maximum profit you can get is 0 because there's no way where you can buy. There's no point at which you can buy the stock and then sell it later on to turn anything that's a positive profit. Okay, cool. So now that we kind of have an understanding of the problem, look, the really easy brute force solution is to pretty much, starting at each element, compare it to the elements that come after it, and then find the greatest difference, right? So the brute force, kind of what we were saying before. So that solution is pretty easy to implement. It's another nested for loop here. So for our outer loop, we want to start at 0, and then we want to go up until prices.length -1, because we're going to be comparing it to the inner for loop, which is going to start at I + 1. Because you don't need to compare two prices to themselves, because that profit is always going to be 0. So we're just going to start at the day after. J less than prices.length, J plus, okay. And then super simple if here. If prices on, so J is going to be the day where we sell, and I is going to be the day where we buy. So if the price that we sell at minus the price that we buy at is greater than our answer, our current answer, right? We're going to do answer is equal to this, because this is the quote-unquote max profit, right? And now for the for loop, we return answer. So this is done, right? Realistically. So if we run this code, okay, cool. We'll submit it. Okay, great. So this is really bad, right? It's taking a long time. It's running faster than 7%. So there's actually 93% of submissions are actually faster than us. And the reason is because it's n squared. It's not complete n squared, right? We're not making any redundant comparisons, and we're only, we're checking all the unique comparisons that we can, but we still are running a nested for loop, and n squared is typically just bad, right? So let's see if we can figure out a more efficient solution. So if we go back to the problem here, ideally, we just need to find the minimum price. So at any given day, right? Like we can really just, rather than having to track both like the day that we buy, the day that we sell, all we need to do is for any given day, find what is the minimum price before that we've seen, what is the lowest price we've seen so far, and then if we were to sell on that day, how much profit would we make, right? Because we don't need to compare one. If we buy at 1 and we know 1 is the minimum the entire, it's the lowest price it's ever going to be, we already know that we want to buy on this day pretty much, right? Especially because the only day before that is 7, which is really high. We don't want to buy at 7, and that's the max, right? But we just want to compare for each one Like, what is the max profit if we were to sell on each day? Because the minimum price will be constant no matter what. So, for example, right, the minimum price being 1, if we sell on day 3, 4, 5, or 6, or 7, or whatever, we're still going to be buying it at 1. That's still going to be the best option. It just matters. The only difference between our profit is where we sell it at. So why don't we just do that? Why don't we just keep track of our minimum so far on each given day, and then we just try and see for each new day past the minimum, if it's not updated, what's the max profit? If it's better than our current max profit, then we'll go ahead and change our answer, right? So I did kind of a poor job of explaining that. I think it'll be a little bit more illustrative when I write out the code. So first, let's do a better job of naming our variables here. So let's have max prof is equal to 0, right? Let's do profit is equal to 0, because you know that's the minimum. It's never going to be lower than 0 because you never have a negative value here. And then we're going to have like min price is equal to integer dot max value, right? The reason we want to send to integer dot max value is that we definitely want to reset this, right? We want to make sure that no matter what element we see in prices, it's going to be less than or equal to what we initialize it to be. The alternative would be to set this to the first element in prices, but we don't have any constraints here, so we don't know if like prices could be empty, and in that case you still want to return 0. So this, like, even if prices is empty, and we'll kind of see this further, we don't even do the for loop, and we'll just automatically go to returning 0 here, which will save us some time and some code. So what we want to do is we're going to check for each integer I in prices. If, first of all, if I is less than our min price, we're going to update it. Then we're going to go min price, right? If I becomes our new min price, we don't have to do another comparison. So I'm just going to do an else if, because once we update our min price, our profit at that point, we don't have to check the profit again, because it'll just be 0, or it'll be the same as what we had it before, right? So else if I is not our new min price, if I minus min price is greater than profit, so if somehow we find a day where we can sell it, and the difference between the sell price at that day and what we bought it at is greater than what we've seen before, then we're just going to update it, right? Profit is equal to I. Okay, and that'll loop through all the elements in the array prices. So let's kind of, again, iterate through this, talk through this again. So we're going to initialize profit at 0. It's going to be the minimum value. We're going to initialize min price to be integer max value. So we know that these are going to have to be updated eventually, right? They either be updated or they'll just stay the same. So for each integer in prices, if that integer is less than a min price, it becomes a new min price. Otherwise, we calculate the profit for selling on that day and our previous buy price. And if that's greater than the max profit we've already seen, we just update our variable. And we iterate through that whole list of prices, and then we return the profit at the end of the day. So let's run this code. Okay, great. Submit it. Okay, that's honestly a lot faster, right? So we went from 306 ms to 1 ms, right? And it was something like 7%. Now it's faster than 97% of stuff, which is great. So as you can see, the reason this is faster is this is a linear one-pass solution. So you just touch each element of the prices list one time, which is far more efficient than if you had to do an n-squared solution, right? So it's doing the same thing, but realistically, when you have these array problems, you need to understand that array access and array searching is O of n. So if you ever need to search it multiple times, you're going to have some time. It's going to take a long time. If you can do it in one pass, it'll be really great, right? And usually with array problems, when you're just searching for basic stuff, there is a one-pass solution, kind of like we saw in twosum, right? Twosum is an array problem brute force. You can also implement a hash map, but you're still parsing an array of integers, right? But just like we did that in one pass to save a ton of time from the brute force n-squared solution, we're doing the same thing here by just being a little bit smart about the values we keep track of as we look through it, right? So that being said, we're going to continue uploading some more array problems. I think it's probably the most basic building block of data structures. It's the easiest to understand. It's essentially just like a list of values. So we're going to keep going on with that. So expect a couple more problems to be uploaded soon. But until then, let us know if you have any questions in the comments, and let us know if there are any questions you've seen during your interview prep that you would love to go over. Okay. See you next time.